Continue our discussion of the final exam review. A radioactive isotope has a decay rate of 0.098 per year. What is the half-life? And round to 2 decimal places. We use the formula A of t is equal to A sub 0 e to the kt. We do not know A sub 0, but we don't really care about having a particular number for A sub 0, because we know that because of the half-life, then the amount remaining will be 1/2 of the amount that we started with. So A of t be equal to 1/2 of A sub 0. So you can plug in that the amount remaining will be 1/2 of the original amount. So 1/2 A sub 0 is equal to A sub 0 e to the kt. Then we can go through and try to solve this by doing some algebra. So divide both sides by A sub 0. So we have 1/2 is equal to e to the negative k t. But we're told that the decay rate is 0.098. So let's plug in for k. Since we're decaying, it's going to be going down, so it's negative 0.098 t, right? And then what we can do to undo this e, we take ln of e. So take ln both sides, and so we have ln of 1/2 is equal to negative 0.098 times t. Then to find t, we divide both sides by this negative 0.098. Then this other side by negative 0.098. Because ln 1/2 is negative and negative 0.098 is negative, so we end up with a positive t. A positive times the t is equal to ln of 1/2 over a negative 0.098. And if you want to find the decimals for that, that's going to be 7.07 something something. So the 2 decimal places are 7.07. Since we're talking about per year, then this will be in years. You're done. Okay. So the next problem is determining the amplitude, period, phase shift, and vertical shift of this number, of this function. So your function is y equals negative 1/4 cosine of pi over 3 minus pi over 3x minus pi over 2 plus 5. So that's number 17 right there we're doing. And so let's identify our different parts. A is equal to negative 1/4. B is equal to pi over 3. C is equal to negative pi over 2. And D is equal to 5. So we want to find our amplitude, period, phase shift, and vertical shift. So amplitude will be absolute value of A. It's going to be absolute value of negative 1/4. That's equal to 1/4. A period going to be 2 pi over absolute value of B. So it's going to be 2 pi over pi over 3. And so that's going to be equal to pi over 6. Phase shift, your formula is negative C over B. Negative C over B. So that's going to be a negative of negative pi over 2 divided by pi over 3. So your phase shift will be 3/2. Okay, now we want to sketch a vertical shift, by the way. It's just D. It's going to be equal to 5. Your vertical shift is also your midline of the graph, of the new graph. Okay, so what you want to do then is if you want to graph this, you want to graph a single period, so one period, or one cycle, one CYCLE will lie between 0 and 2 pi of your pi over 3 x minus pi over 2. And then we solve in this one, we'll just sketch graph one full cycle. So we'll do plus pi over 2, plus pi over 2, plus pi over 2. And so what we have here is pi over 2, that's not equal to pi over 3 x less than or equal to 5 pi over 2. 5 pi over 2. And then we want to divide through by pi over 3. Divide by pi over 3. Divide by pi over 3. Again, what we're left with here is your phase shift is going to be 3 over 2. It's not equal to x. That's not equal to, you divide this one also by pi over 3. You'll be left with 15 pi over 2. 15 over 2, right? 15 over 2, 7 and 1/2. Okay, so what I want to do is I want to divide this point from 3/2 to 15/2 into 4 parts. 4 parts, right? So we're going from 3/2, 6/2, 9/2, 12/2, and 15/2. Okay? And so these are x values. Then to find matching y values, you know that we plotted a cosine function. Cosine function is going to negative. So we want to go, there's going to be a minimum. It's where 3/2 matches that function, your y value will be 4 3/2 somehow. 4 3/2. We know that our phase, our vertical shift was 5. That means our midline of our graph would have been 5. And we knew that our amplitude was 1/4. That means our maximum would have been 5 1/4. And our minimum would have been 4 3/4, so 4.75. So here is our graph oscillating between 5 1/4 and 3.75. And we know that the 3/2 match with 4 and something plus 4.75 or 4 3/4, and the 6 would be at the midline. 6/2 would be at the midline. If you want to simplify that to 3, that's fine. Or 9/2 or 4.5 would be at a max. Or 12/2 or 6 would match with the midline again at 5, and then a 15/2 would match with the max, because this is an inverted cosine curve. So one graph of your curve would look like that. So the next problem we'll look at would be number 18, write the graph of the cosine of the function shown below, right, in the form of a cosine function and then as a sine function. So we're going to take this graph and we're going to find the different parts of it, then as a sine and then as a cosine function. So to express this graph as a cosine or sine of function, we need to find certain things. For example, we need to find the amplitude. Amplitude is max minus min over 2. So it's going to be 3 minus -3 over 2. So that's going to be 3. So your amplitude is 3, or you could just look at the distance from the middle to the top or the middle to the bottom, and you see that it's 3. Now the period is where the graph repeats. In this case, goes from the x values, the graph repeats, so that's from 2 pi over 3 back to 0, so that period will be 2 pi over 3. Then for phase shift, we can look at either left or right, typical start of a, let's say, a cosine function. In this case, look for the x value, so that'd be something like -pi over 3, and you could pick any typical starts. You could have picked pi over 3 as well, but let's choose -pi over 3. Phase shift, -pi over 3. And then from these, we need to find our A was going to be 3. B, yeah, so we know the period is 2 pi over B, so B will be 2 pi over period. So it's going to be 2 pi over 2 pi over 3. So that just gives a 3. C is going to be phase shift times B, so -B times phase shift. So it's going to be 3 times -pi over 3. And so times -pi over 3. That's what we use. So that's going to be -pi. So then our equation then would be f of x is equal to 3 cosine 3x minus pi. And there's no vertical shift. So that's your cosine. For the sine, what we want to do is I want to choose another phase shift. That looks like a typical sine, and so we could choose let's say pi over 6, so we could choose pi over 6 as our phase shift. So let's choose pi over 6. And then to find our C in this case, we just do -B times phase shift. So that's going to be B, which we found was -3 times the phase shift was pi over 6, so C would be -pi over 2. So the equation, or f of x, would be equal to 3 sine of 3x minus pi over 2. And so that there's no vertical shift. So we'll verify an identity: sine theta times square theta minus sine theta over cos theta tan theta plus cos theta is equal to tan theta times tan theta minus 1. So we begin with the left hand side, sine theta, tan square theta minus sine theta over cos theta tan theta plus cos theta. If we factor sine theta in the numerator and cos theta in the denominator, we're left with sine theta times tan squared theta minus 1, cos theta tan theta plus 1. If we factor the difference of squares in the numerator, we have sine theta tan theta minus 1 times tan theta plus 1 over cos theta tan theta plus 1. And then the tan theta plus 1s cancel each other, so we're left with tan theta over cos theta times tan theta minus 1, which simplifies to give tan theta times tan theta minus 1, which is the right hand side, and we are done.